Hey guys, this is part 2 of your 1.4 notes, radicals and rational exponents. So in the first video we talked about simplifying radicals, we did some adding, subtracting, and multiplying, talked about perfect squares and all that. Today we're going to talk about dividing and then rational exponents. Okay, so let's zoom in here on these dividing notes. So there are going to be 3 types of situations that you're going to come across when you have radicals in your denominator. Okay, the first we're just going to use the quotient rule. So this is if you have a radical in the top. So if we have square root of a over square root of b, radical in the top and in the bottom. Remember that you can rewrite this as a square root of a over b. And then if you can simplify this fraction, that works really nicely to get just one number under the radical. Okay, so that's probably the most simple way to do this. If you do have a radical in the numerator and in the denominator, of course, this has to be one term in the numerator, one term in the denominator. Then you always want to see if you can simplify that fraction first, and then it makes it much easier to work with. Okay, the second type of situation you're going to have is if you have a monomial denominator, and this would be if you do not have a radical in the numerator, or if you cannot simplify that fraction, okay? And in this case, you're going to multiply the numerator and the denominator by the same radical that's in the denominator. Okay, so let's say we have 1 over the square root of a. In this case, we're going to multiply the numerator and the denominator by the same radical. So we'll multiply by square root of a over square root of a. Notice that we're just multiplying by 1, so we're not changing the value of this number. We're just kind of rearranging the way that it looks. And then multiplying fractions straight across, you have square root of a over square root of a squared. And if you are squaring the square root of a number, you're just going to get what is under the radical, right? It's undoing that square root if you're squaring it. Okay, and then you come out with a number that has no radical in the denominator, which is simplified. Okay, so if you're ever circling your answer on your homework or on your quiz, it's your final answer, make sure that there's no make sure that there's no radical in the denominator because that is not completely simplified. So all of your final answers, you want to have no radicals in the denominator. Radicals in the numerator, just fine. Okay? And then our third scenario here would be a binomial denominator. Okay? So remember, we're just talking about fractions that have radicals in the denominator, and in this case there's going to be 2 terms in the denominator. Okay, so say we have our fraction is 1 over a plus the square root of b. Okay, because we have this plus symbol here, we're going to have to do things a little bit differently. We're going to be multiplying by the conjugate, okay? And the conjugate is going to be the same binomial, just with the opposite sign, okay? So the conjugate of a plus square root of b is a minus the square root of b. Okay, we're going to multiply the numerator and the denominator by the same number. We're just multiplying by 1. And let's see what happens when we do this. Okay, so if we have a plus the square root of b times a minus the square root of b, let's do our FOIL. So the first 2 terms would be a times a, which is a squared. The outer, we're going to get minus a root b. From the inner, we're going to get plus a square root of b. And from the last, we're going to get minus the square root of b squared. Okay, so let's do some simplifying here. You can see that negative a root b and positive a root b are going to equal 0. And then this guy here, we're just undoing that radical, so we're going to be left with just b. So simplifying this whole answer, this is going to equal a squared minus b. Okay, so if we finish this problem up here, we multiply by the conjugate, we're going to get a minus root b in the numerator, and that's going to be over a squared minus b. Okay, and this doesn't look like a simplified answer, but like I said before, what we're looking for is no no radical in the denominator. So believe it or not, this is actually simplified. Okay, so let's try out, let's do a problem from each of these situations to do some practice. Okay, so number 17 here, we have a radical in the denominator and in the numerator. So first we want to see if that can be simplified. Okay, so we are going to just keep this 6 up here. All right, and let's look. So 480 divided by 6 is 80. Okay, so we can actually combine these two by putting the whole fraction under the radical and then simplifying. So square root of 80. And this is actually going to still be over 2. And you're going to be able to divide the top and bottom by 2. And those coefficients will simplify to 3 root 80. Okay, so we have 3 root 80, and then we want to make sure that we have this simplified all of the way. So let's look at the factors of the square root of 80. See if it has any factors that are perfect squares, and in fact it does. 16 times 5 are factors of 80. And then we can split this up as 3 times the square root of 16 times the square root of 5. We can simplify this to 4, so now we have 3 times 4 times root 5. And our final answer here, we're just going to multiply these coefficients together. We have 12 root 5. Root 5 cannot be simplified anymore, and there's our final answer. Okay, so even when we get here, don't forget that you still need to make sure that your radical is as simplified as possible. All right, let's move to number 20. So this is a situation where we don't have radicals in the numerator and denominator, just in the bottom. So we are going to multiply the numerator and the denominator by the same radical. So we're going to multiply by root 10 over root 10. Okay, so in the numerator, we're just going to have 5 root 10. On the denominator, we're going to have 10. Those coefficients, if we can divide both the numerator and the denominator by 5. That's going to give us root 10 over 2. And root 10 cannot be simplified anymore. It doesn't have any factors that are perfect squares. So that's our final answer there. All right, number 23. Okay, so you can see this is getting a little bit more complicated. We have a binomial in the denominator, one with a square root. Okay, and it doesn't matter if there's roots in the numerator here. If you have a binomial in the denominator, you're going to have to multiply by the conjugate. Okay, so remember the conjugate is going to be the same binomial, except it's going to be the opposite sign. So we're going to multiply the top and the bottom by -1 plus the square root of 5 over -1 plus the square root of 5. Okay, and in the numerator, we're just going to put 4 outside the parentheses right now, so it's easy to see how this is going to go. And in the bottom, when we multiply these, you're going to get your first number here will be squared, and then you're going to get then it's going to be a negative of whatever the radicand is, okay? So here we're actually going to get, we're going to end up with positive 1 minus 5, I believe. Okay, and then let's distribute this top and then simplify the bottom. So we're going to get -4 plus 4 root 5 all over 1 minus 5 is going to give us -4. Okay, so now we have these numbers here that can all be reduced. So if we divide, let's see, we're going to divide the top and the bottom by, let's say, -4, I believe is what we're going to want to do. -4 divided by -4 Okay, if we divide by -4 in the first term, we're going to be left with 1 minus root 5, and that's it. The denominator will reduce to 1, so we don't have to leave a denominator, and then that is our final answer there. Okay, so there's a lot going on here. Most of this stuff you have seen in previous classes, but just like the rest of the stuff we've been doing, you're probably a little bit rusty on that. So make sure you finish up these problems here on the notes. Looks like there's 5 more problems in this section, and then move on to your homework for more practice. Okay, let's look at rational exponents. Okay, when we talk about rational exponents, we're looking at fractions. Okay, so anytime we talk about like rational anything, like rational functions or rational expressions, it's always going to be some kind of fraction form. Okay, so here we have a rational exponent, we have a fraction in the exponent here, and we're going to talk about what this looks like as a radical. Okay, so this is a very important rule or conversion or whatever you like to call it to remember. Okay, when you have a fraction as an exponent, the denominator, okay, will be what your root is going to be, and then the numerator is going to be the exponent of the radicand. Okay, so let's take a look at a to the 1/2. And some of you might already know that this is the square root of a. But if we have a as the radicand, okay, the numerator is going to be the exponent on the radicand, and then the denominator is going to be the root. Okay, so we know that a to the 1/2 is actually equal to the square root of a. That is the same thing. Okay, so if you're ever confused about which the numerator or the denominator, which one goes where, I get confused about that, so I always think back to a to the 1/2. I know a to the 1/2 is the square root of a, so then I know that the denominator is the root and the numerator is the exponent of the radicand. Okay, so let's do some of these problems. It looks like this. Let's do number 25 first. Okay, so we said that the denominator is going to be the roots. The denominator here is 2, so we know that we're going to have a square root. And when we use the square root, you know, as we all know, we don't have to write the 2 because it's implied there. If it's anything other than a 2, you do have to write the root in. And then p to the 9th. That would be the exponent on the radicand there. Okay, so now that we have written this in radical form, just we need to pay attention that this asks us for the simplest radical form, so we do need to simplify this some. So we're asked for the square root of 9, okay, and remember we can write this as the square root of p times p to the 8th, and p to the 8th is actually a perfect square, because if we have p to the 4th squared, that's equal to p to the 8th. So if we take the square root, so we'll have root p times root p to the 8th. If we take the square root of p to the 8th, we're actually going to be left with p to the 4th. Okay, and then we'll just write this as a coefficient here, so p to the 4th root p. That is the simplest form of this rational exponent. Okay, let's do write the simplest exponential form. Okay, so this is going the other way. So our radicand here is 5k. That's going to be our base, 5k. And looking back at our notes over here, we know that whatever the root is going to be the denominator, and whatever exponent is going to be the numerator. So the root here is 4. We're going to keep this cubed in here. So the root here is 4. That is going to be the denominator. And we're going to put 1 as the numerator because we kept this exponent here in the 3. Okay, so if knowing what we know about powers of exponents, this 1/4 is actually going to the 5, and then it will be going to the 3. So if we carried out this powers of exponents, we would have 5 to the 1/4, k to the 3/4. Okay, and then we can put those both have a denominator of 4, and then the exponents of 1 and 3. All right, and then let's do number 29 down here. Simplify each expression, write all answers in the simplest radical form. Okay, so let's look at this first one, g to the 3/4. G to the 3/4 is equal to the 4th root of g cubed. Okay, so I just put the numerator and the denominator of the exponent in their correct places. Okay, and then this is equal to, hang on, I'm getting messed up here. I did this in the wrong order. Let's back up here. Okay, let's multiply these first. I can't read my own notes, sorry guys. Let's multiply these first. Okay, when you have the same base and you're multiplying these together, the same base, you're going to add the exponents. So we're going to have g, and the exponents we're going to have 3 over 4 plus 5 halves. Okay. Let's just quickly add these over here. So we're going to have to multiply by 2 over 2. Okay, and that will give us 3 over 4 plus 10 over 4, which is 13 over 4. Okay, so multiplying these together first, we're going to get g to the 13 over 4. There we go. That's what I had in my notes and I couldn't read it. Okay, so now we're going to write this in radical form, which is the 4th root of g to the 13th. Okay, and we need to simplify what's under here. So we can write this as the 4th root of g to the 12th times g, right? Which these are equivalent because g to the 12th times g is g to the 13th. Okay, and we know that if we have g cubed times to the 4th is g to the 12th, so we can take the 4th root of g to the 12th, and that gives us g cubed. So we could write this as the 4th root of g to the 12th times the 4th root of g. We know that the 4th root of g to the 12 is actually equal to g cubed, and then we multiply that times the 4th root of g. And that matches what my notes say over here. Okay. All right, so still a lot going on with this. You're really going to have to be careful about keeping track of everything that you're doing. Please send me questions on problems that you have, and I will send you videos on how to work them out. Okay, so these videos are a little bit longer because I'm doing more problems as requested. Okay, so let me know if you have more